28. Which expression is equivalent to x to the negative 6, y to the fourth, all over x to the third, y. Okay, so which expression is equivalent to that for all values of x and y where the expression is defined? Well, I want to introduce you to a concept that we've already used. Um, so if I have 10x and then I have 5x, because the variables are the same, I can simplify that to 2x over 1x. Because if I divide the numerator and denominator by the same number, I'm really only dividing by 1. So if I divide the 10 by 5 and the 5 by 5, 5 over 5, that equals 1 because x over x equals 1. It doesn't matter what it is. If you have the numerator and denominator the same, that's what we call the identity property of 1, and we can use that to solve some problems. Well, here's how we can also use that. We can cancel. In other words, we can make this we can make this expression simpler if we cancel some things that are in common. All right, so it works like this. X to the negative 6, y to the fourth over x to the third, y to the 1. A way of thinking about this is you can separate the x and the y. That's still going to multiply with y to the fourth, y to the 1. All right. So what we're trying to do, we're trying to make this thing here simpler. We want to simplify that. So let's take a look at our x. I'm going to scroll down a little bit. X is to the negative 6. That's really a fraction. What if I were to increase the exponent by the same amount? So what if I added 6? I do the same thing to the bottom. So what I end up with x to the negative 6 plus 6 is x to the 1. Or I'm sorry, it's x to the 0. And then 3 plus 6 is 9. Well, the thing is anything raised to the 0 power is 0. I have no x's. I'm multiplying no x's. That's what the exponent says. How many of the x do you have? Well, I have 0 of the x. Okay, so that means x to the ninth with nothing up here in the numerator. And that's okay because remember that this is a set that goes together. So now let's deal with the y. So we'll get the brackets out of the way so it doesn't clutter things up. Well, what if we took one away from each y? We'd have y to the third over y to the 0. So anything to the 0 power goes away. So that's really y to the third over nothing. Normally that's a problem. But let's put things together. If I have an x to the ninth in the denominator, and I have a y to the third in the numerator, that is a legitimate fraction. So let's come on up here. Let's see if that's one of our y to the third, x to the ninth. So that's not the case with D or C or B, but there you have it. Let's see if that's the right answer. Always check your work. I happen to have all the correct answers loaded, but I don't have them memorized. There we go. And so all we did basically is find a way. I'm going to show this one more time. I'm going to show it quick. Right. If I look at the x component, I have a -6 in the numerator. So I'm going to add 6 to that. So I end up with x to the ninth. Then I look at the y component. I have a y to the fourth in the numerator, a y to the 1 in the denominator. I'm going to subtract 1 from the y's. So the y goes to the 0 and just disappears. And that leaves me the y to the third. That's all there is to it. There you go.